So this is part 2 of our review. I'm on visual domain and range, and this question says find the domain of the following graph. So domain is my x values. So I'm going to start from the leftmost spot on the graph over to the rightmost spot. And that goes from -9 to 11, including those points. So I have two choices. I can write -9 to 11 in interval notation, or I can do step builder, which is just using those inequality signs showing that the x, because this is domain, is in between -9 and 11. The next one we need to do on a calculator. So I'm going to get out that Desmos calculator, and you can definitely use the one on Delta Math 2. There's really no preference either way. So I get over to my internet. There we go. So I did absolute value last for a different question. So I'm just going to leave up that ABS, x minus 3, minus 3. This time we are again looking for the domain. It's not definite, but we can kind of get that idea, and plus the nature of absolute value graphs, that this goes from -infinity to +infinity. So going back to our packet, there's two ways we can write this. In interval notation, we can write -infinity to +infinity. And in step builder, we don't usually put infinities with those inequality signs. So when we want everything, we just write all reals. And on Delta Math, that's actually a separate option. You can click the button that says all reals. I'm just going to zoom in a little bit more here so we can see this a little better, hopefully, especially if you're on a smartphone watching this or something. Okay, so moving on to the next one. Use graphing technology to find the range. Okay, so we're back to the calculator. And this one is the square root. So if you type SQ, let me just show you. So SQRT, SQRT gives you that square root. So that's a way you can do that. I'm not sure if there's another way, but that's the way that I know how to do it. So I'm looking at the square root of x minus 2. So range, now we're going in that y direction. So this looks like it starts at -2. Okay, that's my very first y value. And this graph does slowly keep increasing up to infinity. So my range is -2 to infinity. So it touches -2. Remember, infinities always get parentheses. If I wanted to write this in set builder, I don't write -2 with a y in the middle and then an infinity. Remember, we have to use y because it's range. I would just write that y is greater than or equal to -2 because we don't put those infinities with those inequality signs typically. So on to the next problem. Another one where we need the graphing calculator. Now we're finding the zeros. So I'm going to go back over here. And I have 1.2x squared minus 10.2x plus 19. I'm finding the zeros, so I'm going to hover over those x-intercepts. So I see one of them would round to 2.76 to the nearest hundredth, and the other one would round to 5.74. So I'm going to write those two down. So 2.76 and 5.74. Our next one is about relative extrema. This particular question says the function f of x is graphed below. How many points on the graph represent a relative maximum? So I'm looking for a maximum point. This one is just kind of like, slows down and goes again. This is definitely a high point, and that is a high point over here. So there are two relative maxima on this graph. This one asks me about that increasing versus positive. Increasing, decreasing, positive, negative. It wants me to go from -infinity, so this side of the graph, to A. So this is negative because it's below the x-axis, and it's definitely going up pretty quickly. So we're going to say increasing. So you would choose negative and increasing when you did that problem. The next one is another calculator problem. We're going to graph this function and look for the y-intercept. So I'm going to go back to my calculator. I have 2 times 3x plus 4. And then x squared plus 2. So I don't see anything right now. So I'm just going to kind of look around. I might have typed something in wrong. Let's see if. So I think I was in caps lock and it didn't like my x's. That was the problem. I was pretty sure the graph was visible at this point. So we'll go back in a little bit. So we are looking for that y-intercept. I hover and I see that it is at 16. And there are ways to find anything that you find on the graph, you can find algebraically. It's just this unit we're really focusing on the graphs, how to read the graphs, so we're not covering those algebraic methods. Now we're on to average rate of change. I have another one where I have a function, determine the average rate of change of the function over the interval from -7 to 1. So I'm going to put this in that calculator and then get my table for -7 and 1. So we'll go back over here. X squared plus 5x plus 3. Remember the year and the table. So my two numbers I need are -7. And I do have 1 in here already down here. I can see the 1, 9, but I'll just put it up here so I can see both of them. So now I'm going to go back to my paper, write down those 2 points, and do my slope formula. So we have -7, 17, and we have 1, 9. So y2 minus y1 over x2 minus x1 is going to give me 8 over -8, or -8 over 8. In this case, I had my numbers switched when I did it. So this does equal -1 as your final answer. A second average rate of change problem, this one having to do with a graph. So this is a little easier. We don't have to use that calculator. So we want average rate of change over this interval. So I'm starting from -3 something. So -3, 2. Right, that's the point that goes with -3. And then to 14. Set up our slope, 14 minus 2. So these 2 over 2 minus -3 is going to give me 10 over 5, which equals 2. And now we're on to our last page. This is inverses. So graph the inverse of the provided graph on the accompanying set of axes. You must plot at least 5 points. So I'm going to start with these ones that are kind of on the y-axis. They look like they might be important. So I have the point 0, 6. So on the inverse, I would graph 6, 0. I have the point 0, 8. So I would graph 8, 0. This one too, that turning point's probably important. I have -1, 7. Switch x and y again, 7, -1. And then I'll pick some that are out in the tail. So maybe I pick this point, which is, I can't even see on the grid, so I'm going to look at my answer key here. Looks like it's 3, 9. So it's kind of hard to see where it was. Actually right here. So 3, 9. And that goes to 9, 3. And then I'll pick one further out the tail here. So I also have the point 8, 4. So I have 8, 4. And now I'm going to graph 4, 8. So in this general area, I'm going to switch colors just because as I look at this, it looks a little sloppy. So those are my inverse points. Still looks sloppy, but at least I'm color coded so I can tell what's going on. So that's what you would have, and you have to plot those 5 points to get your graph. It could be any 5 points you find. You know, try to stick to ones that involve integers. Lastly, we're going to find the inverse of a function and put it in mx plus b form. So we know to switch x and y, we want to write a y here. And then I'm going to switch x and y, so I get x equals negative 2y plus 4. And then I'm going to move everything over, right? I need to get the y by itself, so I subtract 4. And that gives me x minus 4 equals negative 2y. Then I'm going to divide by negative 2. And that gets me y equals, now I need to get it in mx plus b form. So I need to take this negative 2 and distribute it over the subtraction. So that's going to give me negative 1/2 x for my first term. And then I have 4, did I copy it down wrong? Okay, so, sorry about that. So this was supposed to be a negative 4. Now I'm going to make it a positive 4. Okay, so I just copied that sign. That I did not mean to change it, I just copied it wrong. So then I add 4, okay? 4, positive 4 divided by negative 2 is a positive 2 there. So this would be your answer. And I think on delta math, it looks like this, right? We have f inverse of x equals, so you just fill in that right side of the equation.